Okay, so yeah, welcome. So for those of you who haven't decided, okay, they left. So yeah, there's still a few seats at the front. For those of you who just come in, you can come closer to me if you don't mind. So yeah, like there is actually some hands-on exercise after my presentation. So like you can go to that link to go to that GitHub repo, which is bit.ly and then / PyData LDN22. So yeah, I gave you the link early just because like you know, the internet is not the best, so it may take some time to download. But I would definitely like guide you back to the repo later. Yeah. So hello, how's everybody? How's lunch? Good. Yeah. Good. Okay, good. So I hope you're not too full. So you know, well, if you fall asleep, I hope it's not my fault. So right. So I'm Cheuk. So this is you can kind of I hope you can see well. So like you can follow me on Twitter if you want. So just to like give everybody an idea what we're gonna do. So this workshop actually there will be a presentation to start. So it would take around 20 minutes. This is not very accurate, actually, so it may change. But if I finish the presentation early, you'll get more time to work on the coding. You know, that would be great. So there's this also like another way to find the GitHub repo is to go to my GitHub, which is just Cheuk Ting, my name, and then you would from all my repository you will find the KNN recommender. So that's the one that you should go to. And then I'll try to also like give you an idea of how that project was structured, but I hope you can like kind of, you know, complete the project yourself. So I do believe that the best way to learn is to try it yourself rather than me telling you what to do. But there's also like kind of a solution that I was hidden in another branch. If you really need some help, you can go there as well. So without further ado, so for new people, I love seeing new people. Please come and there's 2 seats here. There's also a few seats over there, so you're welcome to come join us. I think I would just start by giving some kind of background information about what we are going to do today. I hope you already have an idea. If not, then I'm just going to tell you. So we're going to build a recommender. So what is a recommender? So we kind of experience that every day, right? Like if you have subscribed to Netflix, you know that after you know when you join, you have to pick a few movies that you like, and then you get a bunch of recommendations. So a lot of recommender is kind of, first of all, it's kind of driven by data. So a lot of these companies, like Netflix and stuff, they got a lot of data about user because they would probably like see what the user has been watching. So they have lots of data about users and also the items, because like they would have the whole kind of library of movies and shows that they would know some information about it, right? So, so recommender is kind of useful to make some personalized recommendations. So, of course, you can, let's say you start a streaming service that's not Netflix. Then you could actually start by just, see what's popular right now, right? And just recommend that to everybody. I think, yeah, there's some services that do that. I think, we don't know what, like, sometimes we don't know whether it's personalized or not. Sometimes just like all popular stuff will just pop up. But, we want to do a little bit better than that, not just like everybody watch the same set of movies, or all the popular movie will get more popular, and the movie that is not popular as a start, now we get sink down. So sometimes it's like more useful to make personalized recommendation. If I, for example, I know that if you like comedy, I will give you all the recommendation about comedy, right? So. For an online business, it's very important for that because, for example, before this internet shopping thing and internet service that is so readily available, we would probably, let's say, go to a shop, right? Because I remember when I was younger, as a young lady, I loved going to cosmetic shops. So I would go to cosmetic shops and go there, and there would be a salesperson approaching me, and because I would be a potential customer, right? So someone would come to me and say like, what are you looking for? I think this really suited for your skin type and things like that, right? So, so this is like some human interaction there. But nowadays, like, let's say if you buy things from Amazon, like, you don't have a salesperson come and ask you, like, what are you looking for today? Are you looking for cosmetic? Are you looking for electronics? Are you looking for, books and other stuff? So, so for an online business, how can we know what do you want, right? Also, if it's back in the old days, like where there's salesperson, so if you talk to a experienced salesperson, they would kind of, after talking to you for a while, they would have an idea of like what you like, then they would kind of recommend stuff to personalize to what you would like. But if we're doing an online business, then, how do we know? So we use the power of the data, right? So we build recommenders. So there are a few types of different recommenders out there. There's also like something we call a content-based system that is basically we just look at all these different kind of stuff that we're selling and then kind of group them into different groups. Like I mentioned before, movies, you can have comedy, romance, horror, sci-fi, all those, like you can group them by their content. But also there's something called a collaborative filtering system that is based on how people react to different things. We have an idea that, what things should be recommended. I'll go a little bit into details later. There's also a hybrid system. That means, I won't stick with just one method. I will just mix and match. So just a combination of the two, everything else just go into the hybrid category. So content-based system, like I said before, for example, I am currently in love with this Cowboy Bebop anime. So it's anime, not new anime. It's made in the 90s, maybe. I'm not so sure, but like I watch a lot of them. So probably what I would get from recommendation, something more, intuitive would be like, oh, you like Cowboy Bebop the anime? Maybe you would like the live action series that is made by Netflix, right? So okay, so but that's not always true. At least from my experience, I don't like the live action series. So so based on the content, sometimes it hits or miss. For example, movies, right? For example, we love the first movie. I love the first Pirates of the Caribbean movie. But if you recommend me the newest one, then maybe I won't like it because a lot of these movies, we say that, oh, the first one is good, and then the sequel is not as good. So maybe I won't like it. So that's got some drawback there. So if you just base on the content, it's sometimes not very accurate. So collaborative filtering system, that is something that would have more kind of, I would say a little bit more sophisticated. For example, it's kind of based on what people have an opinion about something. For example, a movie that got, if all the people that love, for example, like, let's say, okay, both of us watch a lot of anime. So, if I watch an anime and I think that's good, like Cowboy Bebop, then like maybe it will get recommended to you. So it's just kind of mimic in the real world that if I like certain things, and then maybe I will have friends who like certain things, what will I recommend to my friend, right? So that's more like a collaborative filtering system. There's more user ratings that is involved. But there's a problem because some of the items may be more popular, right? Then more, if it's more popular, then there will be more opinion about it, and the chances are they would get recommended more. But if there's something, let's say someone make a very niche movie, or like some item that is very niche that like is nothing else like it in the market, then I won't get a lot of reviews. Then I'm not sure I understand. Sorry. It happens sometimes. I think it always happens in PyData London. I don't know why. But anyway, so like if something is not so popular, people haven't seen it so much, there isn't got a lot of review, then it won't get recommended, and it's not fair. It's not good. So that's why sometimes we use the hybrid system. But to make things simple, in our workshop, we would just use the collaborative filtering system. So how we going to achieve that? Because we would need some reviews, right? So the reviews that we would get is from MovieLens dataset. I think I do have the link to it at the GitHub repo. So if you already go to the GitHub repo, then you would find the link to download these two CSV from them. Make sure you get the full version. You haven't get to the repo yet. I will show you the link again, but don't worry. So go to the GitHub repo, you'll be able to go to the movie lens data set, and then get these two files from the full version. So you download a full version of the zip file, and then you unzip it, you will have these two CSVs. After that, you put that in the same repo that probably you already have cloned it, so you put that in the same repo, then we can start working. So like I said, this collaborative filtering method actually will have some problem because some movies are more popular, they got more ratings, some of them don't. Also, on the other way to look at things, right? So there are some users that they review everything, but there are some users, they just review a few of things, maybe something that they like the most or something they hate the most, I don't know. But you know, we don't want the maybe like user who just review 1 or 2 movies. So we have to do some filtering for our data. So we'll dive into it later. So yes, so before I go into this detail, I would give people another chance to get the repo. So it's either go to my GitHub, so my name, Cheuk Ting, one word. So github.com, and then put that there, and then KNN recommender, or you can find it in my repo list. Or you can use the shortcut there. That's like bit.ly and then / PyData London 22. So yeah, I hope you, maybe I should give you more time, sorry, I'm just skipping, but yeah. So yeah. Yes?
The full data set looks as if it's going to take quite a while to download. Can we make do with the short data set?
Yes, I think maybe for this workshop purposes, you can get the short data sets for now, I think. But I haven't tried on the short data set, so if it doesn't work very well, it's fine. You can try it again at home when you get the internet. Yeah, but you can make do with that for now, just so we can complete the exercises. So that's a good suggestion, actually. So if you find that, oh my God, like my internet is so bad, then download the small version for now. The large one will take an hour. Okay, that's really bad. Okay, download the small version, sorry. Okay. Yeah. Yeah, download the small version for today, but you can, of course, try it at home when you have time. So while you already I hope we are already in the process of downloading. So let's have a look at what we're going to do today while the thing is getting downloaded. Okay. So first of all, we have to prepare the data. So again, like the problem is that there will be long tail. So if you plot everything as like, you know, plot a user in one axis and then the rating in the other axis, you will see that there will be actually like some user that hasn't been, there's actually a lot of user that hasn't been rating a lot of movies. And if you do again like a movie, and then you will see that actually there's a lot of movie that hasn't been rated a lot. So especially if you're using the full data set, maybe it's less when you're using the small data set, but if you observe that, then probably the idea is that we have to do the filtering. So the way to do it is that we would create some filters, right? So it's just pandas, you know, we love pandas. And then pandas, we can actually create filters that, for example, we can set a threshold that, let's say, if a movie receives less than 50 reviews, then we just ignore it. Or a user that hasn't reviewed, let's say, 50 movies, that's quite a lot, or 10, I don't know, movies, then again, we ignore that. So we just choose the data point that actually is like popular movie and active users. So we got a chance to do that. And then, so actually the way to do it, because like the project is already, the skeleton is already in the repo. So what we're going to do is look for this PyData method inside that, and then it's like pandas. Then we create that filter. And then after that, then we could create the array. So the data that need to, so we will later put in our KNN nearest neighbor, is that we need to be a m by n array. So we will have, so m is the number of movie and n is the number of user. So you can see that it's actually like each, you know, if you look at the m dimension, right? So each one actually represent a movie, and then the user's rating will be actually the vector itself, right? Will be like the characteristic of that movie, judging by all these n number of users. So from there, actually, you can think that when we do the KNN, so movies that got similar rating from similar users, they would be similar, judging by the KNN. So that's what we're gonna do. That's why we have to do the pivot to make that m times n array. It will be clearer when we look at the code, but just get the idea for now. And then, because this matrix, actually the m times n matrix is going to be a huge matrix, right? So this matrix is going to be, again, because it would be rare to find a user that rates every single movie. So there will be a lot of zeros in this array. So we call that a sparse matrix. And sparse matrix, if we represent it in a normal NumPy array, or that would actually cause a lot of memory because we store all the zeros. So if we use SciPy sparse array, sparse matrix, actually it will use a better mechanism to store it. So we just store where things got rated, and it will be more efficient. So we can actually transform it because that's actually it will work in our model as well. So look about our model. Our model will be, like I said, a collaborative filtering model. Is it user-based or item-based? So like I said, the m and n array before, so each vector, so we have m vectors, so each vector is n long, right? But n is the number of users, so each vector is actually representing one movie, so it's item-based, so they are items, they are movies. And then similar movies gotta be clustered together, so if those n users, if they rate A movie and B movie, similarly, then you would get similar vectors, and they will be similar. So if you do that with the KNN nearest neighbor model, then actually, the model will tell you, oh, these two vectors are very close, and I think they are similar. So we got to do that. Also, from the KNN model, again, it will be clearer when I show you the code. So in the KNN model, you can also say, like, how am I going to calculate the proximity of the two vector, and then you can use different methods. One method that we use is the cosine similarity method, which we'll go through in the code. So, yeah, this is where can we get the model? Is in scikit-learn. So in the skeleton of the code, it's already there, just nearest neighbor, but the parameter can be set, so it will be set in another function there. It's like set model parameters. And so inference is the one that we also have to work on a little bit because I leave some code out. Then we have to actually use the model to find the n nearest neighbor from the, get their distance, how far apart they are, and also get we need to find those n similar ones, right? So we need to get the index. So we can later map it back to the title of the movie. So yeah, and then we try different settings as well. So again, it will be much clearer if I show you the code, but let's just let that go through first. Is there any questions for now? No? Oh, very puzzled? Very, very puzzled? But how about the downloading? Is it all good? The small data set? All good? You already got it? Yes, okay, good. Okay, so yeah. So and then after we build it, we'll run the code in the command line first. There's already some instructions in the GitHub repo tell you how to run it. We just need to run it once, then we can try the browser version because we need that pickle file that we'll process the data and then we'll get pickled, and then once we have the pickle file, we can if you run it again, it will be much faster. Also, also it can be run on the browser. So yeah. So yeah, so that's how we gotta do it. So let's also this is like if you want to try the PyScript and the browser version, you can follow these instructions. It's already it's also the instructions on the GitHub repo. So PyScript is the thing that lets you run Python on a browser. If you're interested, there will be a talk about it on Sunday, I think. So yeah. And then so this is I will leave this for later. So let's go let's go to do the code, or at least have a look at the code. So let me go to this. Oh, actually, I already have it. That's fine. Let me zoom in a little bit, if I can zoom in. Control plus, right? Yes. Right. So you already got the project file there. Like I said, download the CSVs, and I put that in the same repo. GitHub doesn't allow me to put the big data there, so I can't do that. So, okay. Oops. Okay. So I hope it's clear enough. No, it's not. Well, if it's not clear, then look at you look at the one in your computer. But I was trying to like go over the code a little bit so I can explain what I just talked about like 5 minutes ago. So this is the skeleton of the file. Credit, I didn't create that from scratch by myself. It's another data scientist, for a talented data scientist, created the code and write the blog post about it. But I do some modification with it, of course. But yeah, that's based on that. So this is the KNN recommender. So maybe first of all, we have a look that we are using a few of the libraries that we know and love, like pandas. We're going to prepare the data using pandas. And we also use the sparse matrix that's called CSR matrix. So we're going to use that later, so remember that. So that's the sparse matrix that we're using. Our model is the nearest neighbor, so we call that from scikit-learn, so it's already there. Also, there was some fussy-woozy thing, which is like, that's mainly used for when you enter a movie name. It's just try to find like, the closest one, right? So, because if you have a misspelling, I think once like fuzzy matching matches, it will still work, so that's fine. So you don't have to type in the exact movie name. Sometimes, we forgot an S or something, so it's fine. Right. So, this is the KNN recommender, so you can see that the line there, this is the important line here. Whoops, okay. So the model is the nearest neighbor. So if we want to use the model, what we gotta do is to call self.model. So instead of creating a new model every time, we create one model in this recommender. So every time we just call the self.model. And of course, when we set it up, there's also some other like settings we could have. We could have the path to the movie and ratings. The default is just the same place in this together with this code. So that's why I said, put the CSV together here. So then you don't have to fiddle around with this setting. Also, there's threshold. Here it just says 0, but we can change that. So there's this is the one that we changed the parameter. We can change the threshold, like I said. So instead of 0, we'd be like, I need 10 ratings, right? So you can have 10 there, things like that. So yeah, so a minimum number of rating received by a user for each movie, or minimum number of ratings a user given. So if a user haven't given, like, let's say 10 ratings, then they are out. If a movie haven't received 10, you can set the other one as 10 as well. So if a movie haven't received 10 ratings by other users, then they're out. So this is the filtering, just to make the things much better. Yes. I think we could, you can set that to 0 as a start, because I think if it's a small data set, I think it's okay to use all of them. This one, the code is based on if we use the full data set. So I think as an experiment, you can just set the threshold to 0 for now. But again, like, it won't be a very good recommender, because we are using just a sample data set for now, just for internet download reasons. But yeah, let's just pretend that the recommender works, unfortunately. So, but yeah, I can show you like where it's actually got set here all the way down. So it won't be set by a user, it will be set by us, who are the engineer. So we are taking a role of engineer. So you can change this into 0 for now, because we're using a small data set. So if you change this to, so go all the way to the bottom, and then change this to 0, then we'll use everything. So try that as a start first. Yeah, since we are using a small data set for now. So, okay. So the model parameters, we can also change the model parameters. Like I said, the KNN, nearest neighbor, there is actually, you can tell metric it used to calculate the similarity between two vectors. So there are different ways here that you could choose the metrics here. You can choose, L1, L2, Euclidean, or cosine. So I think the default here is cosine, but feel free to change to the others when you rerun the model to see if there's any other different changes. Also, there's different algorithm you could use as well. I think algorithm is something that I don't totally understand, so I would just skip that part. But yeah, I think it's just like how it got calculated. Some of them may be more optimal for some data, things like that. But yeah, you can also choose how much, how many neighbors that we're gonna be using. But this will just like be an option that we get from the command line, dash options. So the number will be how many neighbors we get and how many recommendations we would give. So yeah. Okay. So this is PyData is like where we work on. So you see that all this like to-do thing right here is like I leave out the code for you. The original one that is finished, you can see it from the finished branch, but I recommend you to spend some time to fill it in because we will have time in this workshop, so you can try working it yourself or working it with your friend next to you to see like how you can create a filter. So we're using pandas, so really it's just an exercise of filtering using pandas. And then afterward, we have to do the privilege table to make that matrix, m times n matrix that I talk about. And then also we need a mapping because the KNN only give you the index of the movie. So we need to find back the title, that's why we need this mapping, this hash map that we need. Another thing is that we would take that array, the m times n array, and make it into a sparse matrix. So we just use the scikit, the one we got from the SciPy to get this. Yep, so this is the bit that we have to complete today in this workshop. Then you will have something that the data will be prepared, right? So we still have a little bit of things to work on until it will completely work. So for the fuzzy matching, again, it's not the focus of today's workshop, so just leave it be. And then inference is the one that we actually call the model, and then we do the find the k nearest neighbor from it. So so we'll fit the data, so the data is the one that we prepare in the other method. So it will be the sparse matrix. And then this is just like, if you put in the movie title, you just try to find the index by using the mapping and the fuzzy matching thing. And then here to do, this is the important thing. This is like where we actually get the k nearest neighbor from the model. So you get the distance and the indexes. We will have to use that later. So get that, and then you can get a list of the index of the recommendation, and then we have to use the mapping as well to get all the title back. Then we just put it back to the system, and then we can make accommodation. So, oh no, this one is just running the whole thing, yeah. So yeah, so if you complete the inference and the prep data, actually this one will be working. Of course, if you scroll all the way to the bottom here, you can change the setting. Like I said, change this to 0 as a start because we are using a small data set. And then the model parameters, I think you can try the default one, and then but later you can change all these settings. I think mainly you can change the cosine into some like other metrics to calculate the similarity, so you can see whether that makes a difference. And then we can run it. So I think I'll give you time to start working on this. If you have questions, you can ask me. And then, because this is not my computer, I don't think I have Python here, so I can't really run it. But yeah, I would just maybe like give you time to work on it and then ask questions if you have any. So. So yeah, for this model, like I said, it's introductory. I don't think it will be something that you want to deploy for a commercial use because it suffers some drawbacks like popularity bias. It would bias towards the more popular item. You also have the co-start problem. If you, for example, I have a new movie, I haven't received any ratings, it won't work. So yeah, but I hope you had fun today. That's the most important thing. I hope also it kind of give you a starting point if you want to learn more. So like I said, I didn't started this from scratch. There's a blog post that inspired me to do it. The author also has the code there. So if you want to know more, visit the blog post here. I have the link here. Also, the link will be in the repo as well. Check that out. So for those of you who have tried to run it in the browser, again, it's use a PyScript that lets you run Python on the browser. There will be a talk about it on Sunday. So if you are interested, if you like the look of it, go to the talk. You would know more or talk to me afterwards. So yeah, you can find the project repo there. So there's 2 branches in the repo, if I can show you here quickly or not. Yeah, so actually there's 2 branches. So the one that we work on is the main branch here. If you kind of struggling when you try to complete it at home, you can go to the finished branch. That would be the completed one. So you can just run this if you want to see what the finished product looks like. Or if you need a little bit of help, you can have a quick peek of this and then, actually, that's why I'm struggling with, and then come back to your code and fix it. So yeah, I think that's more or less it. If there's no more questions, so you can go and enjoy the coffee. Again, thank you so much for coming. I will be here the whole weekend, so talk to me if you want to. Thank you.